Hello everyone. So here we are taking a question from permutation combination probability, and this question was asked in JEE Advanced 2020. Alright. So the question says this modulus x, that is denote the number of elements in set X. So they have used a notation that this is representing number of elements in some set X. And let set S is 1, 2, 3, 6 be the sample space for an event where each element is equally likely to occur. If A and B are independent events, that means A and B are independent events associated with S, then the number of ordered pairs of A and B such that number of elements in set A is greater than number of elements in set B is greater than equal to 1. So understand, we have to make independent events first thing, and the number of elements in set A and B corresponding to events A and B should satisfy this condition. So let's say for example, number of elements in set A, let's say this is equal to A, and number of elements in set B, this is equal to B. Now if the events are independent, what is the condition? That is probability of A intersection B, this is equal to probability of A into probability of B. That means you have to check the number of elements in set A intersection B also. So let's say the number of elements in A intersection B is equal to C. Okay. So this is C by 6, the probability, C by 6, right? The sample space has 6 elements. This is equal to A by 6 into B by 6. So from this you can say AB is equal to 6C. What is A representing? Number of elements in set A, or the favorable outcomes for event A. Similarly for B, and what is A intersection? C is representing the number of elements common between A and B. Okay, and here you can see if AB is equal to 6, what is the condition which needs to be satisfied? That this number of elements in set A, that is A, should be greater than B, and this should be greater than equal to 1. So now you have to just check how many ordered pairs of A and B can be formed. So to just identify how many combinations, in how many ways you can make this combination under this condition. Okay, so now let's take this. We have AB is equal to 6C, A is greater than B is greater than equal to 1, and A, B, C all belongs to only the set 1, 2, 3, 4, 5 and 6. Number of elements maximum can be 6, right? So now see, if AB is equal to 6C, that means you can clearly see AB has to be the multiple of 6, right? Now since A is greater than B, we cannot have A is equal to 1. This is not possible. B is equal to 1, A is equal to 2 is also not possible, because if A is equal to 2, then B has to be equal to 1, but then AB cannot be equal to a multiple of 6. So minimum value of A can be equal to what? 3. So we'll start with A is equal to 3. Okay. So now we are just trying to make the combinations, like how we can have the values of A, B and C. So I'll just make a table so that it will be clear. So let's say this is number of elements in set A, this is B, and this is A intersection B. Okay. So let's say if set A has 3 elements, that is number of elements corresponding to favoring A, event A is 3, then this is equal to 2, and if AB is equal to 6, then obviously C has to be equal to 1, because we have this condition satisfied. Similarly, if I have A is equal to 4, then obviously it has to be equal to 3. It cannot be 2, it cannot be 1, because we want a multiple of 3, multiple of 6. Then this will be definitely equal to 2. Similarly, if I put 5, now let's take this case, A is equal to 5. If A is equal to 5, then B has to be equal to either 3, 4 or 2 or 1, which is not possible, because in any case A-B product will not be a multiple of 6. So we cannot have A is equal to 5. Now next case, A is equal to 6. Number of elements in set A is 6. Now if A is equal to 6, what can be the values of B? B can be equal to 1. Similarly 6, it can be equal to 2. We can have 6, 3, then we can have 6, 4, we can have 6, 5, right? So these are the possible cases we can have here, right? We cannot have 6 and 6 because in that case A and B both will be equal, but we want A should be greater than B. Okay, so now this is how many elements in set B, set C. This will be 1, 2, 3, 4 and 5. So these are the possible cases of A, B, C. Now understand in how many ways you can have the first case and so on, right? So now focus. If you have number of elements in set A is equal to 3. So for example, consider this case. I'm just drawing the, explaining this with the concept of a simple Venn diagram. Let's say this is set A, this is set B. So what is this first case saying? That number of elements in set A are 3, number of elements in set B are 2, and there is one common element between A and B, set A and set B. So let's say for example, there is one element common, let's say this is 1. Okay. And there are 3 elements in set A. Let's say this is 2 and 3, and there is one element in set B. So for 2 elements in set B. So we can have one more element, that is, let's say 4. We cannot have same elements here. Otherwise, there will be 2 common elements here, right? So you can say in how many ways you can form this. The first thing you can see, this is for C. This is the case for C. I'm writing. Okay. So in how many ways you can have element common 6C1? You can select one element out of these 6 for this common area, right? Now we are left with only 5 elements because one element has gone. Okay, so out of 5 we require 2 elements for A because A already we have one element here. Okay, so this is 5C2. We can select any 2 elements out of the 5 remaining elements. Now how many have gone? 3 have gone. So you are having only 3 elements now because we have total 6 elements. So out of these 3 you require only one element for now set B. So this is in how many ways? 3C1 ways. Out of 3 you will select only 1. So if I just calculate, this is equal to 180. Now understand the second case. Now what is the meaning of second case? You can see here exactly same, like similar to what we have done in the first case. So we have this. Okay, so now set A and set B. Set C has 2 elements common. Let's say this is 1 and 2. 2 elements common, right? C. This is case A intersection B. Okay. Total how many elements are required in set A? 4. So 2 are already there. So we require 2 more. So this is 3 and 4 for example. And for set C we require how many elements now? Set B we require how many elements? We require 3 elements. So we have already 2 elements. So we require 1 more. Let's say this is 5 we have taken. So now you see in how many ways you can select 2 elements for set C, 6C2. We have selected 2 elements, right? Now you are left with only 4 elements because 2 has already gone for set C. Out of these 4, you require only 2 elements for set A now because 2 elements are already there. So this is 4C2. We are selecting any 2 elements, right? Now we will form this set B. So how will you make set B? So for set B you require only 1 element now. So already how many elements have gone? 4 elements have gone. You are left with only 2 elements. So out of these 2 you can select only 1 element, right? So this is how you can find this value. Okay, so if I just check this value, this is 15 into 6C2. You can check, this is 15. This is 6 into 2. This is equal to 90, 180. Right? Now the third case. If I take the third case, what is the meaning of third case? Set A has 6 elements, set B has 1 element, and set C has 1 element. So now this is pretty easy. For example, if you have set A, this is set A. Now all the elements are there, and there is one element which is common between them. So you just select only one element, 6C1. Why we are selecting only one element? Because this is filled. This is already filled. All the elements are here, right? Now automatically this section is also filled because the element which is there will be there only. Okay, in set B also. Okay. Similarly, if I take this, so no need to like into one you can say. Okay. Now, in how many ways you can select the 6 to 2 case? So you can say you just select 2 elements out of 6 elements. So there will be 2 elements common, and these 2 will also be the part of set B. So no need to select anything for B. Similarly, for this 6C3, this is 6C4, and this is 6C5. So these are the total number of ways. Now, what is the final total number of ways of total number of ordered pairs? You can say this is 180 plus. I'll just add them. So you can add 180 plus 180 plus. If you just observe, this is 6C1 plus 6C2 plus 6C3 plus 6C4 plus 6C5. Can we say this is 2 raised to 6 minus 2? This will be the total number of ways. Why this is 6C1 plus 6C2 plus 6C5? This is 2 raised to 6 minus 2 because we know the property NC0 plus NC1 plus NCn is 2 raised to n. So we don't have 6C0 and 6C6. So we have just removed this. So this will be the total number of ordered pairs of A and B. And if I check this, you will find this is 360 and this is 2 raised to 6, that is 64 minus 62. You will find this is 422. So that will be the total number of ordered pairs of A and B which satisfy the given condition. So I hope you have understood this question. Thank you.